Hey guys, welcome back. This is week 5 for the automotive weekly waveforms. If you have not been keeping up with the other weeks, you may want to go back and watch those videos. If you're an experienced scope user, then you could probably watch this and pick up, where we are right now without having to start from the beginning. But what we're going to do is we're going to build on some of the lessons we learned early on, and particularly one of the lessons we learned in week number 4, and that was the relative compression check. Now, I didn't go into depth on what the relative compression check was, what we were looking for. That was one of the first ones where we used a scope accessory. We used an amp clamp, and preferably in clear flood mode, or disabling the vehicle from starting. We crank over the engine and we were watching our voltage waveform and our amperage waveform. Now, we were AC coupling the voltage waveform to take out the DC aspect of it, which makes our waveform a little bit bigger. And what that lets us do is it lets us, kind of blow up or zoom in on that waveform. Not as big of a deal if you're using something like the Pico scope or one of the scopes that you can zoom in on, but on the Snap-on where you can't zoom in afterwards, it's very helpful. But if you have a cylinder that's off, the waveform isn't quite right, how do you know what cylinder it is? That's what we want to cover today. So today's episode is going to be adding a sync channel, SYNC, not the kitchen sink. We want something so we can synchronize our waveform so we can identify which cylinder has potentially low or higher compression, because both low and high compression cylinders indicate a problem. And we're going to need a sync channel for many other testing that we're going to do in the future. So we're going to learn about that. Hopefully we can cover it fairly easy. Unfortunately, with all the different vehicles out there, we have some challenges with getting a ignition sync or some other type of sync. Now, typically a fuel injector sync is not a valid sync channel for this type of test, because while cranking the engine, the fuel injection timing is not going to be in the same aspect of when we're running the engine. A lot of vehicles on crank, they don't fire the injectors sequentially, they fire them in a batch pattern, so they fire them all at the same time. So we don't really know when that injector is firing, or they may fire at a different time. Plus, a lot of fuel injectors fire on the exhaust stroke or right at the very beginning of the intake stroke, depending on the vehicle. Sorry, my dog just grabbed a giant stick. So that presents a problem as well with trying to line things up. Our best bet for getting a sync channel is going to be an ignition sync. Now, depending on the vehicle, we have a couple different options. If it has spark plug wires, we are going to need some sort of secondary ignition pickup, more than likely, especially if it has a distributor, because it only has one coil on a distributor setup, and then that distributor is going to distribute the spark between all the different cylinders depending on what the rotor position is. So we're going to need something like this. This is an inductive pickup. Now, you can get the Handtech one on Amazon for like 18 bucks. I was looking today trying to find a way to build one of these for you guys that don't have them, but honestly, your best bet's just to pick one up off the internet. They're fairly inexpensive and you'll have quite a few uses for it. So this has a little metal end, so you open it up, put it around the spark plug wire. Now, my Toyota that I'm testing today has very small wires. This is probably an 8 or 9 millimeter opening. The spark plug wires on this are 5. You can still get a signal out of it. It just may not be as clear as we want. The other thing we have to watch is this Toyota is a waste fire setup. So it has 6 cylinders and it has 3 ignition coils, which means each coil has to fire twice, because when it fires, spark goes in, and it doesn't go in both directions, but it makes a loop. It goes from the block through one spark plug, back to the coil, and then from that coil through the next spark plug. It has 3 spark plug wires, and then the coils are actually sitting right on top of the spark plugs on the other side of the engine. So we have to analyze our waveform a little bit, the ignition waveform, and see which one has the higher firing voltage, so we can identify which cylinder was on compression. Now, I'll cover that a little bit more once we get a waveform. And even if you can identify or cannot identify which cylinder's firing based off of that, at least you narrow it down to 2 possibilities of which cylinder has the low compression. If you're doing a Subaru, which it seems to be a pretty popular vehicle in this group, just because they're so easy to access and do testing on. Most Subarus are a waste fire setup as well until you get like a 2014 and up. And that's when they went to coil on plug on most makes and models. But everything older than that is a waste fire setup, one coil block that has two separate coils built into it, and the plug wires go from the middle of the engine down to each spark plug. So that's the same thing. You'll be narrowing it down to 2 cylinders, but if we can analyze that waveform slightly and see which one has the higher firing voltage, then we can identify exactly which cylinder. And then, like for this test, my Toyota, there's not a real easy way to disable the fuel injectors. And if I do disable the fuel injectors, more than likely it's going to disable our spark as well. So we may have to pull the fuel pump fuse or relay to prevent the fuel pump from running so that we can get the capture we need. So what I'll probably do is I'll probably try to find the fuel pump relay. We'll have to crank it or run it until the vehicle dies. Crank it a few more times until the fuel rail's out of fuel and the pressure has dropped down so that we aren't intentionally changing our compression by trying to fire, and then we can get an accurate waveform. If you don't have one of these and you're running a snap-on unit, it's a little more expensive, but I do like the secondary pickup from Snap-on if using the Snap-on. I have this with their Virus ignition kit, and it comes with this and an RPM sync. Now, don't buy the whole kit unless you have a 4-channel scope, because the RPM pickup plugs into the DB9, or it looks like a serial connection at the top of the unit, and that is for just the RPM pickup. It won't plug into the 2-channel scopes unless maybe it plugs into the Vantage, but check and make sure you have the port on top of the scan tool. It's this you probably can't even see it. It's this funky one. It looks like an old VGA pickup. So what I'm going to do is I'm going to hook this up to, I don't know if I can get to cylinder 1, because cylinder 1 is my ignition coil. So I may just have to hook up to the companion cylinder, which I think is number 5 on this one. I'll have to look it up. I'll have to look up the firing order, which we're probably going to need anyways. And then the other option is if it's a coil on plug vehicle and has a coil on each cylinder, depending on which type of coil it has. If it's a 2-wire coil, then the computer is directly firing each one of those coils, and we can back probe that coil and get the primary side of that coil, which is the computer's work, and we can get it that way. But if we're doing it that way, we need another accessory. If you're using the Snap-on scope, you don't, because the Snap-on scope has attenuators built in. It can handle up to 400 volts, but when an ignition coil or an injector fires, after it fires, it has a kickback voltage that can jump way up close to 400 volts. Typically you see 200 to 300 depending on the vehicle, but sometimes they jump a little higher than that. This little device, which once again it's hard to see, is a 20-to-1 attenuator that I use on my Picoscope. Picoscope, the maximum input voltage on mine is 100 volts, so that kickback voltage exceeds that level, and you could burn up the scope by not using an attenuator. So my scope came with 4 of these because I have a 4-channel scope and I bought the deluxe kit. Handtech also makes these fairly inexpensive on the internet. And then I have a couple of adapters to go from the BNC to the banana jacks, because I'm going to use a new amp clamp today. It is a 2000 amp clamp, which of course, as soon as I turned it on, after I unboxed it this morning, I left it turned on, but this new one has an auto off feature. So I do need to disable auto off, because I don't think it stays on long enough for me to film this video. To disable auto off, hold the button while I switch it on. So I hold the reset button, flip it to 2000 amps, let go. Now the light is red and it shouldn't power off. I'm just going to clamp this around my negative battery cable, and I'll make sure the polarity is correct. Positive going that way, back into the battery, I think. And then I want to talk about another setting on our scope as well, because we saw when we were doing the last waveform that our voltage and our amperage are opposite of each other. So voltage drops as that starter is pushing that piston up on TDC. It's doing a lot of work. Starter's doing a lot of work, is using extra power, and the voltage drops in the battery. If we're looking at the amperage goes up at that same time. Well, what if we want our voltage waveform to represent or look like the amperage waveform? We can do that with the scope. All we have to do is invert our voltage channel. So if you don't have the amp clamp and you're just using battery voltage, all you got to do is check mark the invert feature, use the invert feature of the scope, and it's going to flip that image upside down, and it's going to look just like the amperage waveform. The amp clamp is going to have a little more clarity, but it'll still look very close. So I'll do that today. Since I have the 4-channel scope out, I'm going to use 1 channel for voltage at the battery, so channel 1, and I'm going to invert it, and I'm going to AC couple it. So everything's going to be riding on that 0 line. Channel 2, I think I'm on channel 2, is going to be my amperage. And then channel 3, I'm going to hook up to the secondary pickup. I think, actually, since I already have channel 4 empty, I'll hook this up to channel 4. This is my secondary pickup. Before I hook it up, we'll look up the firing order so I know which cylinder I'm hooking up to. And then channel 3, we're going to hook up to the primary side of that coil. So we're going to jump over to ProDemand. Actually, we're going to go Identifix. Identifix, I think, is the easiest one to find the firing order, so that's what we're going to use. Of course, we have to go through their new login page, which is very redundant. It opens up in a new tab, and I hate it because I have to, close another tab. Let's see. And I'm a distance away from my Wi-Fi, so it might be a little slow. And we are working on a 1996 Toyota 4Runner. With the 3.4 liter engine. And number 1 on the list is firing order. All the way at the bottom of the screen, we're going to click on firing order. So 135 on the passenger side of the engine is our bank 1, 246 on the driver's side. The coils are mounted directly on the spark plugs on the driver's side. So it's going to be difficult for us to tie into that and get our waveform. So we're going to hook on 2, 4, or 6. I want to do the companion cylinder. So if the firing order is 1, 2, 3, 4, 5, 6, then we want to be on cylinder number 4, because if you just cut the firing order in half, take the other half. So if we go 1, 2, 3, we go the other way. 1, 2, 3, 4, 5, 6. 1 and 4 fire together, 2 and 5 fire together, and 3 and 6 fire together, because they share an ignition coil. And I'm losing daylight here. Try and find my cylinder number 4. Now, one thing I hate about the snap-on pickup, and I keep saying that I'm going to fix it, is the length of the ground cable on that pickup. And I don't know if it makes a difference if you connect that ground cable to a different ground potential than the rest of the leads. So I'm going to move my ground lead over to the intake manifold so that I'm looking at the same voltage plane and I don't have a voltage differential between the two. Hope that makes sense. Now I need to look up how my fuel pump is powered, because I'm pretty sure I can't disable the injection without disabling the ignition. So I'm going to look for my fuel pump relay. I prefer ProDemand for that diagram. Now, if you have a vehicle that works in clear flood mode, problem solved. Clear flood mode will fire the spark plugs, but it will not fire the injectors. So you just hook up to cylinder number 1 or whichever channel you can get to easily to sync it up, and then you can go into clear flood mode, hold your foot to the floor. The newer Toyotas have a relative compression mode. With the scan tool, you activate that, and as long as you don't cycle the key off, it'll stay in that mode, and you can crank it over. This older one, I cannot do that. So we need a wiring diagram. I also want to hook up one of my channels to the primary side of that ignition coil. Even though that won't tell me which cylinder is firing, the secondary is the only way I can do that. It'll give me the sync for looking at, one of 2 options when that coil fires. So I'm just going to go to wiring diagrams, system, engine performance, 3.4, and let's go to our ignition coils. They're all going to share power. I want to go on the negative side. So over here we have ignition coil 1, 2, and 3. They all share the black and red, which is the power, and then the other wire is the wire that's actually firing it. So I need the red wire. Got my blue channel I'm just gonna back probe the red wire, maybe. Wire harness is pretty brittle. Okay, I won't know for sure if I have that connected properly until we fire up the vehicle. And now we need to look for our fuel pump, how that's powered up. Okay, our circuit opening relay is what Toyota calls the fuel pump relay. Below the left side of instrument panel our instrument panel, center junction block. So let's see if we can find the circuit opening relay, the actual location of it. Circuit opening relay. Okay, so it shows it right underneath the fuse block. Hopefully we can access that easily without having to take the trim panel down. Otherwise, it may be easier if I grab another vehicle. Before I remove that, I'm actually gonna just start up the vehicle and make sure that I have good waveforms from all of my connections. We're gonna open up the scope multimeter, go to lab scope, 4-channel scope. Channel 1, since I'm going to AC, you guys can't see me. Channel 1, since I'm going to AC couple it, I'm going to go to 1 volt. I'm going to invert it, and I'm going to AC couple it. We want to move that up a little bit. Channel 2 is my 2000 amp clamp. We can go probably a 1 volt scale. Actually, I didn't even look to see what the scaling was on this thing. Does it tell me? So 1 millivolt equals an amp. So if I probably go to 500 millivolts, that would give me 500 amps. If I exceed that on the initial crank, that's fine. I just want to look at probably 150. We may drop that down even more. It's probably about 150 millivolts or amps once I get the engine going. Channel 3 was my secondary or my primary. So I need to bump that up. That's going to be at least 200 and maybe 400. And then channel 4 is my ignition probe. So on the snap-on, I can hit the little icon that looks like a test lead, and I am going to go to ignition. And it's going to turn on peak detect. Inverted, I don't know if that channel is going to be inverted because on a coil unplug waste fire setup, one fires positive, one fires negative. So we'll leave it inverted for now, and we'll leave it at 20 kilovolts. Now I can start up the vehicle. I can make my final adjustments here, and then we will disable the fuel and get our waveform. And it looks like we are. Now it's a little harder to see. So I can probably change my scaling a little bit on channel 1 once we start recording again, trying to change it while we're on this screen. But we can change that to where, actually, it's probably fine. But you see how channel 1 is a little noisier than channel 2 where my amp clamp is hooked up? That's because we're AC coupling that battery waveform. We're zooming way in on that 12 volt signal. We're going to have a little bit more noise. We could try turning on filtering for that channel, see if it'll clean it up a little bit, because we don't need all of the information. We just want to be able to compare the peaks of our waveform. And since I inverted it, now instead of my voltage valleys going down as that engine comes up on compression, they're going to be going up, just like the amp clamp. So everything here looks pretty good. I'm going to go ahead and disable fuel. I'm also going to change that one channel to add the filter. So we're gonna hit record, we're gonna turn on filter, we'll turn on channel 4. So we have that extra ignition sync, and we're still triggering on the ignition for that coil. So let me crawl underneath, disable fuel. We will give it a couple chances of cranking, run all the fuel out of the fuel rail, and then we'll be able to get our waveform. So it didn't try to fire at all. I'm going to zoom out, make sure that everything looks fine, make sure I didn't disable any of the spark plugs while doing that. And then I'll go ahead and take another capture, but this next time I'm gonna put my foot to the floor. You get the best and most accurate waveform if you have the throttle held open. That's when you do the best compression test. So I'll get another capture with the throttle held open. That's gonna give the most chance for air to fill those cylinders and be able to see the difference in that cylinder sealing. Just gonna zoom in a little bit here. Make sure that we have everything we need. Okay, we're seeing our red, which is our secondary pickup. We have the yellow, which is compression waveform, and we have the green, which is amperage. I'm gonna change my scaling on the green next time I do the recording. I don't like how small the peaks are. I want those peaks to be a little bit bigger. Our yellow looks a little bit better with the filtering on. And we can see our blue, which is our ignition trigger. So we hit record. Let's go to 200 millivolts, 200 amps on the cranking. And now I'm ready to get my good capture. So I'm gonna go in there, I'm gonna put my foot to the floor, I'm gonna crank it over for 10 seconds, jump back out here, hit the stop button, and then we can analyze the data. Zoom out. Now keep in mind, you can do this with 2 channels. All we need is our voltage or amperage, one or the other, and then a sync channel. I'm just doing it with the 4 so you can show you both ways of getting the sync and both ways of getting our relative compression waveform. So what we want to see on the screen is you have to get enough time on the screen to where you can see all 6 of the cylinders or all of the cylinders firing. If it's a 4-cylinder, you just need the 4 waveforms. It's nice to capture more just so if it's a GM and you have a lifter problem and it hits a flat spot, sometimes you won't see it on just one rotation of the engine. Sometimes you have to get several in there. But at least when you save the waveform or view the waveform, it's nice to have all 6 cylinders on there or all the cylinders at the same time. So because this is a little bit messy, I'm going to turn some stuff off here. I'm going to shut off my my 2 sync channels just to show you the difference between the amperage waveform and the inverted battery voltage waveform. And I could have AC coupled my battery voltage or my amperage waveform to make it line up better at the 0 mark, and it would line up just like my voltage waveform. But right now it's sitting a little bit higher. We can actually see what the amperage is. But see how those 2 waveforms look identical? So you don't have to have the amp clamp to do this test. You can do it just off the battery voltage, AC couple it, invert it, and then each one of your peaks is a compression pulse. If we look across here, I'm just looking at one of the grid lines right above the peaks of my cylinders. Now it looks like I have one that's a little bit low. Let me drag this. So this one right here, where I'm moving that cursor around, there's no easy way to point to the screen, is a little bit low. So let's see if that one repeats. So from here, we're gonna count. We don't know what cylinder this is because I'm not showing you the sync yet, but we'll say it's number 1, 2, 3, 4, 5, 6, cylinder number 1. It's another low cylinder. So I have one cylinder that's a little bit weaker than all the other ones. So here's what we're gonna do. We're gonna turn the sync back on. Now, since we know that my amperage waveform and my voltage waveform look the same, I'm gonna disable one of them. So let's just disable the amp clamp. We'll say that you don't have an amp clamp. We'll disable that one, and we're just gonna look at the battery voltage inverted with a filter on it. And then now, let's turn on our blue channel, which is the ignition sync that we are plugged into the back of the ignition coil. Unfortunately, because of this waveform's at the coil, the waveform is going to look the same for cylinder number 1 and cylinder number 4. We won't be able to tell exactly which one is which. Let me make this bigger again. We'll move the amperage up. Now, yeah, it looks a little bit different between pulses, but sometimes that happens. So we won't take too much of that into account. Let's just zoom back in here. So you see how I have a pulse here, here, and here. Every 3 cylinders, we have an ignition pulse. That's because that coil is shared between 2 cylinders. So where is our low cylinder? Our low cylinder is right here. We can see that that yellow trace is lower than all the other ones. So we know that it is on cylinder number 1 or cylinder number 4. It's on one of those 2 cylinders. So now we just, cut the testing in half of what we actually have to use a manual compression gauge on if we were going to check compression. It's number 1 or number 4. If we got rid of our primary signal and switch over to our secondary signal, let me turn that on. That might give us a better indication of which cylinder is which, because if the cylinder, since it fires both ways, and we're on the spark plug wire, so that spark plug wire is going to get spark even when that cylinder is on exhaust stroke. We're going to get it on the compression stroke when that piston's going up and compressing that air fuel mixture. We're going to get spark. Piston's going to come back down. It's going to come back up to exhaust stroke and push that air out. But when it's on exhaust stroke, the companion cylinder is going to be on compression. So we're going to get spark on the exhaust stroke. But it's going to be really easy for that spark to jump the gap on the exhaust stroke. There's not a lot of resistance there. So we're going to have a secondary pattern that is high, and the next one's going to be low. Next one's going to be high because we're on compression. Next one's going to be low because we're on exhaust. And it's going to be repeating high, low, high, low, high, low. Not hello. So let me turn off our blue channel, which was our primary side. We're just going to look at our secondary side and our battery voltage. So the 2 channels, if you're using a 2-channel scope, this would be all you need. So we can see right here. Now the pulse right here and right here, that's just noise jumping over from the other spark plug wires. The other spark plug wires are very close to my pickup, so we're going to get a little bit of noise from those. But our main pattern is right here and right here. Well, you see how this pattern is very, very low? It's not a real high spike, but this pattern is. We get a nice big spike. That one's kind of low as well, or high as well. Okay, I don't really like that capture. So what I'm going to do is I'm going to turn that back to 20 kilovolts. I'm going to change my time base just slightly. We're going to go 20. I'm going to have to move my scope closer to me so I can shut it off a little bit faster. And we're going to crank it over again. Okay, from this zoom level, we can see it a little bit better. I'm just looking at the red spikes. We have a high spike. We have a low spike, we have a high spike, we have a low spike, we have a high spike, we have a low spike, we have a high spike. So I'm going to zoom in on one of the higher spikes. That high spike is going to be cylinder number 4 on compression. And then we can bring down our voltage trace. And now if we look, so cylinder number 4, 5, 6, 1, 2, 3, 4 is just off the screen. But cylinder number 1 appears to be my low compression cylinder, because we know that this is going to fire the same time as this cylinder is firing. And I have my lower pulse right here, which means that number 4, which is the one I'm synced to, is on exhaust stroke. Number 1 is on compression stroke. So if I went through and actually manually checked my compression waveform or compression with a gauge, cylinder 1 is probably going to be a little bit lower than cylinder number 4. And it repeats going the other way. So we're on 4, 3, 2, 1. That one is low as well. Let me try zooming out just one level here. So we can actually see it. So I have my tall ignition spike here. So that's cylinder number 4, 5, 6, 1, which is my low cylinder, 2, 3, 4. We have a higher spike again on the red, 5, 6, 1, which is a low spike again, 2, 3, 4. We have the high spike. So based off of this, now I know this was a long video and that's a lot of information, but if I just came out here and hooked up to the vehicle 2 channels, my battery voltage inverted, ignition lead around one spark plug, looked up the firing order, disabled my fuel. This probably would have taken me 10 minutes. This 10-minute test just proved that I have a low compression cylinder by whatever percentage it is. We don't know how much lower it is, but we know that we have a cylinder that's lower on compression than all the other cylinders. We know that it's cylinder number one. Based off of this information, I can say, okay, we have some sort of mechanical issue, whether it's in the valve train, whether it's in the compression rings on that piston. We have an issue that is causing low compression. Now, where's that compression going? We don't know. It could be going in past the rings, it could be going past the valves, it could be going past the head gasket, which I hope not, because this is the one we did head gaskets on. But we have a issue. We'd have to get deeper into the mechanical testing to prove where it's going. So that is going to be our waveform challenge this week. Do a relative compression check with a channel to sync it up. However you do that is fine, whether it's a single cylinder ignition, whether it's a secondary ignition on the spark plug wire or a control on the ignition coil. If you have an ignition coil with more than 2 wires, like a 4-wire, then it's normally going to be a smart coil that has an igniter built in, and your waveform is just going to be a small pulse. It's going to be like a square wave from the computer. I know we haven't covered ignition coils at all in this except for today, so let me know if you have questions on that. If not, hopefully you'll get a vehicle in the shop that has a ignition coil that you can probe. I know we have a couple guys with newer Toyotas. Those Toyotas with that 3.5 liter engine or the 4.0 liter engine are going to have smart ignition coils. And what you're going to do is there's going to be one terminal labeled IGT on that ignition coil. That is going to be a 5-volt square wave typically. So you won't need the attenuator on that one. You'll just back probe that wire and set your scope up to a 10-volt scale. You will get a little square wave pulse when that coil is trying to fire. Time base on the snap-on, I had to crank it up a little bit higher than I normally would, just because it was hard for me to identify which cylinder was which. So normally I would do like a 50 millisecond waveform. I had to jump it down to 20 to see that pulse, just because I had so much noise on the ignition system. On the Pico scope, you can probably do like a half second per division. That way you can zoom in. You might even get away with a full second per division, 10 seconds on the screen, but you're gonna have the best chance of zooming in if you're on the half second per division or 5 seconds total on the screen. I took this over by the door of the vehicle so I could hit the stop button as soon as I was done cranking, because at 20 milliseconds capture time on the snap-on, the capture goes off the screen, off the buffer very, very quickly. And that's it for this video. If you have questions or comments, put those down below. I'll try to get back to you as soon as you can. I hope I covered everything thoroughly enough, but I know that some of the stuff that's second nature to me, I don't always cover in enough detail. So let me know if I missed something. If you guys are enjoying the series, make sure you're subscribed, click the bell. If you like the video, give it a thumbs up. Thanks for watching, and I'll see you next time.